All right, welcome to tonight's lesson. So in this lesson, we are going to look at the combinations. And then apart from that, I'll also introduce the binomial theorem. But before we talk about the theorem, I'll see first if I can introduce the Pascal's triangle and how to use it. Yeah, so this topic is basically just on the introduction of binomial. All right, so let's quickly begin. Right, so in case you want to contact me or you want to have my line or you have any questions or you want to join the lessons, you can use any of these lines on the screen and then contact me either on WhatsApp, Telegram, on using email. Yeah. So these are the contacts that you can use to even ask questions if you have any questions. Okay. Yeah, so today seems like there's a bad network, but I think we'll manage. Yeah, provided you are able to get me clearly where you are, it's okay. All right, so we have this question here. So before I can even start talking about this question, I would like first to make you understand what they mean. If you are given anything that is in this format, so we have the first one is 7 choose 4. So before I talk about or I solve 7 choose 4, the first and most important thing is the formula. So if they give you n choose r, what does this mean? So what this means is that you're going to have n factorial on top, then you're dividing everything by r factorial, then open brackets. Then from there, you have n minus r factorial. So this is what it means. So whenever you have anything that is in this format, n choose r. So sometimes this can also be written as n choose r. So whether you see this or this, the formula is still the same. Nothing changes. Okay, so let me write properly. So I'm saying if you have n choose r, this one is just equal to n factorial over r factorial open brackets n minus r factorial. Okay, so what does this same symbol factorial mean? What does it mean? So if they say n factorial simply means we're going to list we're going to have n as our first value, and then in the next the second value there will have n minus 1, and then the third one will be n minus 2, the fourth one will be n minus 3. It goes on like that. Okay, so what this means in terms of numbers, if you've been given to find 2 factorial, so 2 factorial will be, the first number will be the same n, which is 2. Then in the brackets, we're going to have 2 minus 1, which is, we're going to have 2 minus 1. Yeah, so this is just the same as 2. Then in brackets, 2 minus 1 gives us 1. And the answer gives us what? 2. So if they say 3 factorial, we're going to have the first value, which is the 3 there. And then from there, we're going to have 3 minus 1, then 3 minus 2. And then, yeah, so we end there. So from there, we're going to have 3, and then 3 minus 1 there gives us 3 minus 1 gives us 2, and then 3 minus 2 gives us 1. Okay. So this is what it means. So in other words, so I mean this one, so finding this will give us 3 times 2 times 1, which is just 6. So in other words, if you've been given, let's say 4 factorial is simply just, you follow this same pattern which is there. You're just removing 1 from each number. Hence, you're going to have 4 times 3 times 2 times 1. So this is the value for 4 factorial, which you can also write as 4 times 3 factorial. Because I know to say 3 factorial here is what? Is 6. Yeah, so you can write it that way. If you want, you can write it as 4 times 3 times 2 factorial, or you can write it as, yeah, I think these are the ways that you can. So the reason why I'm showing you is we're going to be applying them somewhere, more especially in the theory. Okay. So if they say find 5 factorial, 5 factorial is simply just 5 times 4 times 3 times 2 times 1. Then you just have to multiply the numbers. 5 times 4, 20 times 3, 60 times 2, 120. So the answer there gives us 120. Okay, so let's now apply the formula to solve what we have there. So we have 7, choose 4. So 7 choose 4 is now going to be, let me write the formula here. So we have n choose r. N choose r is equal to n factorial over r factorial, and then we have n minus r factorial. So 7 choose 4 is simply just going to be 7 factorial as the numerator, and then the denominator there we're going to have 4 factorial, which is r factorial. And then we have in brackets there 7 minus 4 factorial. Okay. So this is what we are going to have. So now let us simplify this. So on top there we have 7 factorial. Then down we're going to have 4 factorial. Then 7 minus 4 gives us what? 3 factorial. So what we have here can also be written as 7 times 6 times 5 times 4 factorial. So 7 times 6 times 5 times 4 is just, times 4 factorial is just 7 factorial there. And then down here, you're going to have 3 factorial and 4 factorial. So this is what you're going to have. Okay. So now, if you look at the numerator there, we have 4 factorial, also have 4 factorial down. This is the reason as to why when writing 7 factorial, I ended at 4 factorial. If I wanted, I would have ended at 3 factorial. It's still fine. So from there, I can write the remaining figures on top. We have 7 times 6 times 5, everything divided by 3 factorial there, which is the only remaining figure there, can also be written as 3 times 2 times 1. So what we do is we now cancel out what we now divide in the number. So 3 can go into 3 once, 3 can go into 6 2 times. So this 2 and that 2 will go. So the remaining numbers are just 7, 5, and 1. So we have 7 times 5, which gives us what? 35. And then down there, we only have 1. So the final solution is what? 35. So I'm just trying to show you the steps that you are supposed to follow. Otherwise, if you want me to show you the shortcuts, I'm good at that. I'm very good at shortcuts. I can show you the shortcuts here, and you think these things are very simple. Yeah, but anyway, I only do that once. Okay, what I do is whenever I'm teaching, I like first showing the students what I like showing the students the correct formula and the correct steps to follow. And then afterwards, when they are used to following the steps, that's when I show them to say, here, if you want, you can just do this. This is what okay, that's how I like doing it. All right, so, okay. Even the formula that I'm going to show you after solving these questions, it's still not a shortcut because it's the one that John Bate uses. So it's not a shortcut. It's also a correct method. All right, so we can we can proceed. So I've solved this one. The answer is 35. Let's move on to the next one. So one thing you have to understand again is that before I start solving B, is that if you have n choose R, n choose R gives the same answer as n choose n minus R. What do I mean? So if you have, let's say, the one that we had there was 7 choose 4. So 7 choose 4 gives the same answer as 7 choose 7 minus 4 will give us what? 3. So it gives us the same answer. So 7 choose 4 gives the same answer as 7 choose 3. So this is the thing that I want us to apply here, because if we take 19 there, we're going to spend more than 30 minutes, or not really 30 minutes, but it will take us a lot of time to finish solving the question. But if we apply this, it's going to be a very short method. I mean, a very short solution. So I said n choose R is the same as n choose n minus R. So we have 21 choose 19. So 21 choose 19 is just the same as 21 choose 19, rather 21 minus 19. The answer is what? Is 2. So 21 choose 19 is just the same as 21 choose 2. And when we solve this, 21 choose 2, the answer is just going to be, so on top, we're going to have 21 factorial over, down there, we're going to have, so down we're going to have 2 factorial, then in brackets, you still have what? 21 minus 2, that would be 19. I think this is the one that will give us a long procedure, because 19 factorial here, okay, still fine. So we have on top there, we can say 21 factorial can also be written as 21 times 20 times 19 factorial, because I know to say on the denominator, I have 19 factorial there, which you come and cancel with my 19 there. So there I will have 2 factorial times 19 factorial. So this 19 factorial and that will go. So I'm just going to remain with 21 times 20. Then down there, 2 factorial is simply just 2 times 1. So 2 there, 1, 2 there, 10. So 21 times 10 there, the answer is 210. So the solution to 21 choose 19 is simply just equal to what? 210. Do we have any questions here? I want to show you the shortest method of doing this, if you don't want to follow these steps. Okay, so 7 choose 4. We use the short form of solving it. So 7 choose 4, I'm going to draw the division line. So I'll start first by writing the 4 factorial down there. So 4 factorial means 1 times 2 times 3 times 4. Or if you don't want to write it like this, you can start with 4. You can say 4 times 2 times, 4 times 3 times 2 times 1. So you start with what is down there. So okay, let me be using brackets, maybe. Brackets will make sense. So we have 4, then we have 3, then we have 2, then we have 1. Then on top there, I'm going to start from 7 going down. So I'm going to start from 7. So I'm going to start with 7, then 6. I'm starting with the number that is there. 7, 6, then we have 5, then we have 4. So I'm going to end at 4. And the reason why I'm ending at 4 is because I have to make sure that the number of numbers on the numerator is equal to the number of numbers on the denominator. So the denominator, we have 1, 2, 3, 4 numbers. And even on the numerator, when you start counting from 7 there, we need to have 4 numbers. So we're going to have 1, 2, 3, 4. So from there, we can just start canceling. This and that goes 3 into 6, 2, 2, and that 2 goes. So I just want to remain with 7 and 5. So we'll remain with 7 and 5, and then on the denominator will just remain with 1. So 7 times 5 gives us 35. Same applies to 21, choose 19 there. 21, choose 19. So 21, choose 19. Like I said, we first have to change this. This will be 21, choose 2. So this 21, choose 2, we're going to write it as, so we start with writing what is down there. So 2 factorial. 2 factorial is just the same as 2 times 1. So now, since on the denominator there, we have 2 numbers, the numerator should also have 2 numbers. So we'll start writing the numbers, starting with the same number that we have there, which is 21. So we're going to start with 21. Then from 21, we're moving to what? To 20. So only write 2 numbers because on the denominator, we only have 2 numbers. So this 2 into 20 there, the answer is 10. So 21 times 10, the answer is 210. So let me give you another example. Another example is the same. Okay, let me get 8, choose. Okay, I'm getting 8, choose 3, the same number, the same one which is there. So 8, choose 3 is going to be, so I'm going to draw the division line. I'll write 3 factorial, so which is 3 times 2 times 1. Since I have 3 numbers down here, so the numerator should also have 3 numbers. So I'm going to start with 8. So I have 8 times 7 times 6. So these 2, let me start with, okay, 2 into 6, the answer is 3. So this 3 and that 3 cancels, meaning we're just going to remain with 8 and 7. So what you just need to multiply is 8 and 7. So when you multiply 8 and 7, you're getting 56. So the solution there will therefore be what? 56. So this is how simple it is to solve combinations. So we have 2 ways in which you solve combinations using the format of n choose r, which is n factorial over r factorial n minus r factorial. Or you can follow this method which they use in the John Bed book. It's also very simple. So you can choose whichever is simple for you. So let's solve part C, then we move on to the next question. So part C is 8, choose 3, plus 8, choose 4. So how do we add such combinations with the same value of n? So such combinations, simple. So let's first use this formula. N choose r is equal to n factorial over r factorial, open brackets, n minus r factorial. So we apply this, this one here. So we are going to have, okay, if a question was asking us to simplify, the method that I'm going to show you would have been the only way to do it. But since it's asking us to find the value, you can, if you want, you can first find the value of this alone and also find the value of that alone, and then you add them, you still get the same answer. But let me show you a general way of doing it. So the general way of doing this is, we say 8 factorial over, so down there we'll have 3 factorial, then 8 minus 3 will give us 4 factorial. Then we have plus, this side will also have 8 factorial, Then the denominator there, we say 4 factorial, then 8 minus 4 gives us 4 factorial. And then from there, what we can do is we can now, so if this side, oh, sorry, this one's supposed to be 5, not 4. Because when you subtract 8 minus 3, the answer is supposed to be 5, not 4. So we have 5 factorial there. So this 5 factorial can also be written as, so we have 8 factorial there, then 3 factorial. So 5 factorial can also be written as 5 times 4 factorial. Then here we can also write, so we have 8 factorial there. You can also write 4 factorial as 4 times 3 factorial. Then we also have 4 factorial there, which is there. Then we can see that 3 factorial, 4 factorial, and 8 factorial are common. So we can factor them out. So we have 8 factorial over 3 factorial. Sorry for that. Have 3 factorial and 4 factorial. These are common. So what we're going to remain with in the brackets will be 1 over, here on this part, we just remain with 1 over 5. Then on this other part, we just remain with 1 over 4. So from there, we are going to have 8 factorial outside over 3 factorial, and then we have 4 factorial. Then we can open the brackets there. Then we find the common denominator there. So the common denominator is 20. So 5 into 20, the answer is 4. 4 times this one there, the answer gives us what? 4. Then we say plus 4 into 25. 5 times 1, the answer is 5. So we can simplify this further. Then we're going to have 3 factorial, 4 factorial, open brackets. So we'll have 4 plus 9, or rather 4 plus 5, the answer is 9 over 20. So when we multiply this, 9 times 8 factorial on top, and then down there, this 20 can also be written as 5 times, this can also be written as 5 times 4. So we can write 20 as 5 times 4, and then we have 5 times 4, then times 3 factorial, then we have 4 factorial. So this is what we have there. So 9 times 8 factorial can also just be written as 9 factorial, because we know to say 9 factorial is just the same as 9 times 8 times 7 times 10. So meaning, instead of writing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we can just say 8 factorial. So this is why there is 9 times 8 factorial, I've just decided to replace 9 factorial. So once you do that, it's now easier for you to look, it's now, here now what we can do is to look at the denominator. So 5 times 4 times 3 factorial can also just be written as what? 5 factorial. And then we have that 4 factorial there. So this is how it is. So the combination that can be written in this format is simply just 9 factorial over, oh sorry, let me write in terms of the combination. So it's simply just 9, choose what? Choose 5, or 9, choose 4. So if you are told to simplify, if this question was asking us to simplify, it means that this is where you are going to end. It means that you have simplified. But there's what? There's a but. So if you have been told to simplify, this is how you leave your answer. But if the question is asking you to find the value or to evaluate, like for instance, in this case, it means that you have to find the final answer after simplifying. Or you do what I told you in the first place, that you can first find the value of this alone and also find the value of this alone, and then add the two answers. You still get the same answer. So to find the value of 9, choose 5. We simply just have to evaluate what we already have there. So 9 factorial can be written as 9 times 8 times 7 times 6 times 5 factorial. Then down there we have 5 factorial times 4 times 3 times 2 times 1. So 5 factorial and 5 factorial cancel. Then 4 into 4 into 8 we have 2. 3 into 3, 1. 3 into 9 we have 3. And then 2 into 2, 1. 2 into 6 we have 3. Then we can just multiply the figures there to get the answer. So when we multiply the figures, we have 3 times 2, that is 6. 6 times 7, we have 42. 42 times 3. So 42 times 3 will give you 126. So the final solution will be 126. So this is how you find the answer. So if you want, you can first find the solution for this alone, and then also find the solution for this alone, and then you add them. The answer that you're supposed to get should be equal to 126 as well. All right, so let's quickly move on to the next question. Or do we have any questions on this one before I can proceed? Okay, so we proceed.